So the basic outline for today's class is we will be covering what NLign is. We'll go over some of the storage basics, how NLign stores data, model view, what trendables are, and next week we'll be covering the results table, adding and editing trendables, as well as damage map. Okay, let's go ahead and get started. NLign is created to basically acquire information, capture the information about corrosion, cracks, dents, defects, or other records that you need. NLign and NCheck can both capture the information. NCheck is a separate software that we have. It is more optimized for the documentation side and for use on tablets. So it's kind of meant more to be used out on the shop floor. But NLign can also acquire and record information as well. NCheck and NLign can both tie those records and that data to specific 3D CAD locations on your model. NLign has the additional feature of being able to map photographs on top of the 3D models. So you can get really accurate pictures and maps on your 3D models of the extent of corrosion or cracks, basically mapped and drawn onto the top of your CAD or FEM models. And then that information can be exported to finite element analysis packages to help with repairs and analysis. NLign is meant to be a data archive of all the repairs and analysis that has been done in the past. And that's all stored on a server, the NThread database. And NLign specifically shines in helping to analyze that data. So you can perform some root cause analysis. You can watch growth over time of, say, like a crack. You can perform some hot spot analysis on specific locations or parts and look across various serial numbers, tail numbers in the fleet to find out what's going on. So NLign was created in response to some of these structural integrity challenges and just manufacturing challenges as well. Of data is not in useful form, or there's a delay in getting it, and maybe it's not organized or it's not correct. Maybe measurements aren't quite as accurate as you want them to be. Engineering dispositions are maybe ad hoc, and it's, you have different dispositions with different engineers. It's maybe siloed in separate organizations or with different engineers. There's document discrepancy, there's incomplete or incorrect information. There's undocumented maintenance actions that might be happening, incomplete documentation. So a little bit about my history. I came from aerospace material review board at United Technologies Corporation. We were working on thrust reversers. And one of our biggest issues that I was working on was trying to get accurate information. The data coming in was incomplete as well as inaccurate. So to do our stress analyses, we needed better location information from the shop floor. And so we acquired NLign, and the number of discrepancies that we sent back to the floor for clarification went down by, I think, 50%. So NLign helps to address these issues by visualization, hotspot analysis, really accurate measuring. I talked about mapping the picture on top of the CAD model. You can store engineering dispositions into the database as well as stress analyses. Talked about the 3D mapping. You can match the photograph on top of the CAD model. There are all kinds of data verification tools within NLign to make sure that the data being typed in is according to the data that you want to see. So you can put different formatting rules on top of the different fields and make sure that the data coming in is complete as well as accurate. You can make certain fields required and help with your data clarity as well. There are also features where you can directly import NDI data into NLign, and that can also help with aligning your data and providing location-specific information. This is an example of NCheck. It's optimized for touch input, tablet screens. Like we talked about, you can go to a certain record in here and look at the previous stress analysis, historical dispositions, durability and damage tolerance analysis that was done previously. So you can pull up all the previous records that were done on previous corrosion or previous damage records. Quick example of the spatial clustering tool. The larger the sphere and the more red the sphere, the more records are located in there. So you can quickly see that the tip of this part is where the most records have been created, and that's where the largest issues are. So there's been multiple scrap dispositions on the trailing edge, and so you can start to drill down into some root cause analysis. You can dig into these specific records at this location to find out what's going on. There's also different color coding information you can have to look at your different types of records. So that's kind of a quick overview of NLign. It's, really short terms, NLign is basically a 3D database that helps you organize, perform analysis on, and keep track of and improve the quality of your data. So NLign stores information in different ways. Some terminology that I'll be using throughout this class I wanted to go over. So there are models and assets. A model is any 3D CAD, FEM, shell model. Some examples of the file formats of that could be a CATIA, a JT file, a finite element file, IS file, a step. And an asset displays the different model and governs the security rights of who gets to see that model. So you can have multiple models. You can have like the engineering model in an asset as well as the finite element model, as well as a surfacing model. So I like to think of assets kind of like the representation of the aircraft or a specific part. And then the models are kind of like different layers on top of that show you different pieces of information about that specific aircraft. So you can have multiple models inside an asset. You'll hear the word trendable, which is a name that NLign invented. Trendable is basically just data record that you can find trends for. We talked about getting quality data into your records or into your trendables are basically a collection of all the individual fields of data that describe a specific defect, a specific aircraft, a specific person. So you can have various different fields that describe a trendable or a record. So a trendable type determines which fields that specific record has. There could be a trendable type for inspection, and that might have who is performing the inspection, what was the date of the inspection, what was the damage found on this inspection. And then you could have a separate trendable type for discrepancy, trendable type, or record type. You might have fields such as what was the size of the defect, the location of the defect, what was the extent of the damage. So each trendable or each record is a single instance of the trendable type.
Like, what are the options to input data into NLign? Is it just something you do from a tablet, a computer? Could you do something like fill out a paper worksheet and scan it in and then have it automatically take those and put them into digital records? If you have like a shell model on a piece of paper and you annotate on the paper where you're seeing issues and scan it and then have automatically take that paper version to a digital map, is that something that could be done?
It could, with a caveat. So you could treat that piece of paper as a photograph of the part, as long as that printout on that piece of paper was to scale. What I would suggest, if you have some legacy data, that's probably the only way you can do that. Perhaps the aircraft is left, or the part is no longer, can't find it to get a picture of it. So as long as that was to scale, you could do some actual damage mapping with that. You can overlay that picture of the piece of paper, or that scan of the piece of paper onto the model, and then highlight the area that was circled on the paper as the damage area. NLign can take input as far as any document can be attached to a record, whether that's a PowerPoint, a PDF, a scan, a photograph. You can basically attach any type of file type to a record in NLign. So yeah, you could. Does that answer your question?
Yeah, thank you.
Going forward, I would highly suggest just taking a picture. A picture would just be so much easier. So there are other pieces of information in NLign that are stored either dependent to an asset or independent of an asset. Models, like we talked about earlier, are stored within the asset. The specific filled out trendable or instance of the records are tied to the assets. The named regions, the stored views, and the folders are all asset dependent. Those pieces of information that are asset independent are trendable type. So remember, the asset represents something like an aircraft or a part. So the trendable type is what fields are required to document a crack or a corrosion. And you could have corrosion across multiple different aircraft or multiple different parts. Different lists and fields, different color presets, filters, or data sets, and digital camera lists. So to be able to find and select the assets, if you go File, Select Asset, you can open up multiple assets at the same time. So you could open up several aircraft, you could open up several parts at the same time, When I was using NLign, we worked in a manufacturing facility that made thrust reversers for various different programs. And so sometimes I would load up multiple assets at the same time to look at the records across the plant. I wasn't interested just in a certain aircraft's thrust reverser. I was interested in the entire plant's records of defects. I could look and see if, defects in the plant for dents went up or defects in the plant for FOD went up, things like that. So typically people only load one asset at a time, but I want you to be aware that it's perfectly possible to load up multiple assets at the same time. And that can be really helpful in determining certain pieces of information. This is kind of showing the breakdown of the asset is a torque deck, and a specific trendable type could be an inspection. You can have other trendable types like a discrepancy trendable that are tied to the same inspection. It's set up such that you can create a parent trendable and then have children trendables or records tied to that parent. So let's say you found 3 different discrepancies during an inspection. In the inspection record or trendable, all you have to fill out are, who did the inspection, what was the date, where was the building it was done in. So kind of header information, if you want to think about it that way, that describe the inspection. And then on each of these individual discrepancies that was found, all you have to do is link it to the parent, and you don't have to fill out those pieces of information again. So you only have to fill in who inspected it, the date, building it was done in, who signed off on the inspection. You can take those various fields and just enter them in once and then apply them across all the different findings or discrepancies that were recorded in the trendable. So trendable types can be created to represent any type of data or record. You could have non-conformance trendable types. You could have damage mapping, inspections. You could have different trendables that talk about serial number tracking, about specific aircraft, flight hours on certain aircraft. You can even have like training records. You could say certain stress engineers, and then have they received certain types of training. And then you could correlate that record against who was buying off on the records and see if they had the proper training to sign off on certain records. NLign is very customizable as a database and can be configured to do all kinds of different things. It's not limited just to recording corrosion or defect. You can record all types of various information that you might need to be working with for your job. Any question about kind of the setup or structure of the database? So this is the model view of NLign. In the main screen of NLign, it can show a representation of the asset or the aircraft. And all these dots across the model basically represent different records or trendables that have been associated to this model. To be able to navigate the model, it's similar to many different CAD packages that are out there. A chart or a key to help you with the navigation of the model. Pan, you can rotate. You can reset the rotation point. You can zoom in and out. You can select a specific item. Just wanted to demonstrate some of those. Resetting the center point basically changes where on the model you're rotating about. So I could set it at the front if I'm more interested in navigating around the nose of the aircraft. Or if I've got some information I'd like to see at the aft end of the aircraft, I can reset the center point to aft. And it's easier to rotate about the tail and look at the propeller. You can also pan.
So can you overlay the data for multiple aircrafts onto one model to see hotspots and trends?
Yes, so that's one of the benefits of NLign is you can see the entire fleet on a single aircraft. You can overlay all the corrosion from the entire fleet onto this picture of the aircraft. So I'm going to go ahead and apply this default data set, or basically a blank filter, and pull in all the data from the database onto this aircraft. All the dots here on the landing gear could represent 30 different aircraft, and there's multiple records here of maybe different corrosion on this bracket. Just quickly, I wanted to cover clustering because we talked about that a little bit. NLign has a tab called clusters, and if I click generate cluster, it'll generate these different spheres that represent the density of records in that area. So I can change the radius of these spheres the radius in which it looks for different records and how many records it needs to have to create a cluster. So if I arrange these, this large red sphere contains 204 records. This orange sphere, right?
Correspond to the size of the sphere, or they mean something else?
So yes, the more red the color, the more records are within that 25-inch radius. The larger the sphere, the more records are within that 25-inch radius. So in this orange,
something where the colors maybe it indicates severity of the records versus just the number of the records? Or...
Yes, you can. That is a very good question. There are color presets. So right now, all these dots are orange. There are different color presets that I could apply that could change the color based off of different filter criteria. So I could color everything based off of what was the damage type. I could color everything based off of the size of the corrosion. I could color it based off of the date it was recorded. I could color these dots based off of the, I don't know, maybe the base at which they were found, or where the aircraft was flying. Quickly and easily see, hey, we're getting a lot of corrosion south of the equator, or near the equator, but not so much the extremes. So I could correlate, I could color these based off of any field of data that I'm recording for that trendable, for that record. Within this orange sphere, I've got 152 different records, and I could isolate this. And then if I bring up a results window, I can see that the majority of these findings, all these findings, are NDI findings that were recorded here. So I'm going to go ahead and clear that cluster. Fresh. And so in the view window here, I have...
I noticed in your data set that I think for the home base location, some of them said Patterson, some of them said Wright-Patterson. I assume that's just an inconsistency on the data input, but I could see that causing problems when you're trying to filter the data. So is that a manually keyed in entry, or is it like a drop-down window? Can you set it to be a drop-down window if you want, just for consistency's sake?
Yes. So if you put in a text field, people can type in whatever they want. They can type in Wright-Patterson, they can type in Patterson, they can type in WP, they can type in their name on accident. And so the most powerful field within NLign is a list field, because you basically force them to select only the entries that you've loaded. So that's one of the ways that you can get more quality data. This is kind of a test environment, and so yeah, people have put all kinds of different things into here. So it's not as tightly controlled as I would recommend our customers have, as far as making sure there's list fields, making sure that there's formatting patterns on, say, like serial numbers. So let's, the most powerful field is the list field. But let's say you have some serial numbers that you don't know the entire set of serial numbers that are going to be created. But you do know that every serial number is going to start with, I don't know, let's say 2 letters, a dash, and then 4 numbers. You can add that formatting rule into NLign such that if anyone tries to enter 2 letters, a dash, and 3 numbers, it's going to spit back an error and say, hey, we need 4 digits after the dash, not 3. So if anyone does a typo and gives you 3 or 5 or anything that's not 4 digits, it'll spit back an error and say, please check your, you can customize what the error says to be something like, please check your serial number format and try. On this view window, I wanted to go through several of the tools up here. One of the major ones here is the different data sets. This is basically what different filters do I want to apply to this. So I could apply one that says, just show me the corrosion records. And so there are 34 different corrosion records on this aircraft. Looks like the majority of them are here on the landing gear. Or I could apply the default data set, or the default filter, which basically brings in every record that has ever been recorded on this aircraft. And some of our customers have gotten to the point where they have so much data on the aircraft where you can actually turn off, you can hide the model, and you can see the outline of the aircraft from all the records that have been recorded. And then we just finished talking about the different color presets. And here I've kind of divided it up more by crack severity. I can have, bounds in which if crack length is larger than or equal to 45 thou, it's going to be red. If it's less than 40 thou, it's going to be yellow. Less than 30 thou, it's blue. Less than 25 thou, it's green. So this can kind of give me a spectrum of where my largest defects are occurring on the aircraft. Like I mentioned previously, I can edit these color presets to be basically anything. This one is a color preset based off of damage type or record type. So I could quickly go through and see which records are which by looking at this one. So and then to edit them, choose one here. I would just click on edit this color preset. Here I've configured which trendable type or which record type each of these colors stands for. Change the name. I can make this public or private. There we go. Okay, so over here, there are several different ways I can view the records on my view window. One of them is I can view them as points, and the other way is to actually view the outline of the defect. So dealing with corrosion, this can be really helpful seeing the extent of the damage. I can see where the specific record actually went to. So some of these records don't have an outline of the damage, and that might be because they were some type of record that didn't involve an area. Maybe it was a very small dent. Maybe it was some type of part number status, such as flight hours or something like that. So not all records are going to have this outline of the damage of corrosion or crack, but many of them could, as you can see here. So it can get messy occasionally if you're showing the annotation or the outline of the damage, so you can toggle that on and off. You can also toggle if the center point is shown. And so this way you can just see the outlines of damage as they've appeared on the part. We've talked about the 3D clustering a little bit. There's also the option to have 2D clustering. And with 2D clustering, similar to 3D, I can adjust the threshold for how many records should be, how large something should be before it's into a cluster. And as I manipulate the model, the clusters adjust to what I'm seeing in this 2D frame. So as I look at it head on, there's 890 records within this 2D section of this model. There's 4 records here, there's 34 records here. As I adjust it, you can see the squares kind of jumping around, trying to capture the different records. I can come in here and adjust this to whatever sensitivity I need to derive some meaning from these clusters. There are other toggles here for showing text for a selected trendable or showing a color legend. So we talked about the color presets before. This one is showing each individual tail number. As you can see, it gets really messy. So if I didn't want that there, I could just toggle off the show the color legend, and that would disappear. Another toggle feature that I have in here is show detailed text for selected trendable. So if I highlight a specific trendable or record, there's this quick access text over here that will show me the XYZ location, the depth, the length, the width of this trendable type, which is a dent. So I clicked on a dent. So if I don't want to see that, if that's obscuring my view, I can toggle that off. So now it just shows the model on which I clicked. So let me turn off 2D clustering here and go over to the Layers tab. So the Layers tab is similar to the tree in the 3D CAD modeling softwares. You can have these upper level assemblies and then all these part numbers. So if I click on a specific part on the aircraft, it will jump to and highlight that part in the 3D CAD model tree. And vice versa, if I, let's say I know a specific part number, but I don't know exactly where it's located, I can type it up here into this search bar, or I can just click on it. And it will highlight where that part is. Another feature of this tree is if I right click on this part and I say go to, it will zoom into as well as hide any obscuring parts so that I can see what this part number is. So this CFLF is one of the ribs, right? So similar to other CAD packages, I can hide and show. I can change how the parts appear. So I can change this part that I've highlighted to wireframe. I can change it to solid. I can change it to transparent. These little eyeball icons indicate whether the part is hidden or shown. So if I toggle here, if I click on the eyeball or the eyelashes, it turns the part visibility on and off. I can also click on these icons up here at the top. So if I hide all the models, then it basically makes everything disappear. And you can somewhat see, we've started to get enough data here, you can kind of see the outline that there's some wings here and the fuselage here. Turn everything transparent and you can look inside and kind of see the ribs and the struts and the spars. Wireframe. Or I can make it all solid again. So when I highlight a specific part, I also get this interactive input down here. If I want to, I can toggle the visibility here, as well as changing the model color. So if I want to highlight to someone that this is an area that I'm working on, I could change this red or some other identifying feature and take some pictures of it. Or if I take it off, it defaults to whatever the preloaded model color was from the CAD package. Similar, I can show the wireframe here. I can make it transparent, toggle the transparency, or make it solid. Make it hidden here. Another way I can hide and show things is with the H key on the keyboard. So if I hit H, it toggles on and off the hidden or shown portion of that model. So also on the Layers tab are different stored views. So stored views can be really helpful in snapping to a particular location or visibility of a specific model. So here I've got a default, a front, a landing gear, an NDI inspection, safety of flight, UAV no skins, and a wireframe view that have all been saved. So if I click on these lightning bolts, it'll bring me into the pre-configured view of the aircraft. So when I click on the lightning bolt wireframe, it brings me to a wireframe view. When I click on the no skins view, it brings me to this view that shows me all the interior structure of the aircraft. When I click on this landing gear, it zooms me in really close to the landing gear. So this can be helpful if you've got a specific engineer who's always working in a certain area, or you've got different divisions working on certain areas of the aircraft. You can set up these saved views or these stored views to snap to the area that you're interested in. And to do that, you just click on the eyeglasses with the plus icon. So that creates a new stored view. Another way to look at the model is to toggle through the standard views of the model that you typically have in a CAD package. So like front view, side view, top view. So those are pre-saved. Those are like pre-saved stored views. I highly recommend creating your own views of the aircraft so you can quickly snap to the areas that you're interested in. If you click on the gear icon here, you get the access to the center point, as well as adding a ground plane to your view. So the ground plane can be helpful as you look at the X, Y, and Z location of your aircraft. And the ground plane also has these green crosshairs on it that will tell you where 0, 0 is for that plane. So if you're ever kind of lost or wondering where 0, 0 is on your aircraft, you can look at these green crosshairs and see that 0, 0 is on the tarmac for this aircraft. There are also clipping planes similar to other CAD packages. So by default, the clipping plane is automatic. And so as I zoom in to the aircraft, it will start to allow me to go into the interior of the aircraft as I zoom in close enough. And as I zoom in close enough, it goes into the interior body of the aircraft. But sometimes that cannot be all that helpful. Let's say you want to see the interior of the aircraft sooner. So if I turn on the clipping plane sooner and manually edit it, I can adjust where the clipping plane starts. Unlike other CAD packages, NLign's clipping plane is always with reference to the camera angle. So if I hit OK on here, and then I rotate the part about, the clipping plane will change where it's cutting. So you can see as I rotate about the aircraft, the clipping plane is changing, the clipping plane stays constant with respect to the camera view. So it's not at a preset location in XYZ space, it's with reference to the camera view. Okay. Then the last feature that we're going to go over today is how to save the current view to an image file. So let's say I've got a really nice view here in my view window, and I'd like to, I don't know, maybe send this in an email, put it on some type of a report for someone who doesn't have NLign. I can save this current view to an image file. It will ask me what I want to name it. I can go ahead and save it to my desktop or another place. I can also copy that to a clipboard. I could generate a specific report. And that's a feature that I'll go over later in class, as well as export the annotation of a selected turnable. Again, another feature that I'll go over a little bit later. But I want to show that they're here, except for to edit the data set. Right? So those are all the icons and the features of the view window, the layers tab that we covered with the pre-saved views, as well as the part tree. Clusters that can quickly and easily see where the different records are on the aircraft. And then the different data sets or the different filters that you can quickly apply to just see corrosion on the aircraft. Just see the corrosion records. As well as the different coloring schemes that can also help you see what's going on the aircraft. So next week, we'll dive into data sets as well as the results window.